What's up, guys? I'm going to show you everything that you must know about multiplication. Let's get right into it. All right, guys, so this is your challenge problem for this lesson. Given a plus b is not equal to 0, show that the natural log of 1 must equal 0, okay? Now, if you already know how to do this, go ahead and solve it, and you can check your answer with mine at the end. But if you already know how to do this, go ahead and skip this video. You're good to go. If you don't know how to do this, I'll give you this hint real quick. It's solve for x first, okay? All right, so let's get right into it. I want to show you this trick for easy mental math, okay? So when I described in the addition video is that numbers are composite objects. And what that means is that you can break up numbers into other numbers, okay? So what I'm going to do here is just break up 47 into 40 plus 7 and then multiply by 30. Now when I do this, I have to use the distributive property, and I'm going to do 30 times 40 plus 30 times 7. That's going to be 120 plus 210, and then it's going to be 330, okay? So just a quick way that you can do mental math, right? Okay, now I want to talk about converting decimals to fractions, okay? So let's start with this first one. 0.3, that's equivalent to 3 over 10, all right? 0.3 repeating, that's just 1/3. And then this number here, right, it looks kind of nasty, but again, you're just going to divide by 1 with however many zeros is required so that you have one more digit on the bottom than on the top, okay? Hopefully that makes sense. All right, guys, so I want to show you this super cool trick, all right? So guys, here's my question for you. Is 0.9 repeating, is that equal to 1? All right, guys, now some of you already know this trick, but I want to show you because I think it's super cool, all right? So our first step is we are going to define x as this 0.9 repeating, okay? Then what I'm going to do is I'm going to multiply both sides by 10 here, okay? So what's going to happen is all the 9s are going to be shifted over by 1 digit, right? So now I have 9.9 repeating, okay? All right, now what I'm going to do is I'm going to take this 10 value and I'm going to subtract off the x value that we defined as 0.9 repeating, okay? So again, 10x minus x, where x is just 0.9 repeating, right? So I'm going to get 9.9 repeating minus 9 repeating. Now, guys, look what happened. All of these 9s are going to be canceled out because we subtracted off by all those 9s, right? So the 9 repeating, right, the 0.9 repeating minus 0.9 repeating, this is going to cancel out, okay? All right, so now we have 9x equals 9. So when we divide both sides by 9, look at that, guys, we get x equals 1, okay? But x also equals 0.9 repeating, right? Because that's what we defined it as up here. So therefore, 0.9 repeating has to equal 1, okay, guys? Just a little math trick, but I think that's kind of interesting, right? If you have an infinite number of 9s that repeat in the decimal place, that is actually, in fact, equal to 1, okay? Okay, so I want to talk about the distributive property now, okay? So most of you guys already know, so it should be review. But basically what we're going to have to do here is anytime you have this number or variable outside here, and you have these values inside, you're going to first start with the first one, then you're going to go to the second one, then you're going to go to the third one, and you're going to add them all up, okay, guys? So what it's going to look like is this. We're going to get these 3 terms right here, okay? All right, guys, but what if it looks like this? What if the number on the outside of the parentheses is on the right side? Does it change anything? And no, it does not change anything. You're just going to do the exact same thing. And again, the order doesn't really even matter here because it's just addition, right? And the commutative property states that the order of addition does not matter, okay? So there's something to remember there. Okay. So now, guys, I want to talk about the FOIL method, okay? So this is basically like the distributive property, but on steroids, okay? So instead of just having one value outside the parentheses, we have 2 values that are both in parentheses, okay? So the FOIL method, right, the F stands for first, okay? And what that means is that you're going to take the first term and you're going to multiply it by the first term and the other one, okay? So these are our first terms. The O stands for outer, so that means that we're going to take our first term and we're going to multiply it by the outer term. And then inner, or the I stands for inner, okay? So it's going to be this y multiplied with this x, right? It's like this inner space right here, okay? And then L stands for last, which is going to be our last terms, which is going to be y and y, okay? So what we're going to get then is we're going to get our, we're going to get all these values, right? And then we're just going to add them all up, right? Now, when we simplify it down, we get this value here, and that is our answer, okay? All right, guys, now, I used to use the FOIL method. However, what I realized is that this method might actually be even quicker, okay? So you can always comment below, tell me which method you like better. But what you can actually do here is you can split this term up right here. Sorry, that was bad. Sorry, let me rewrite that. What you can do is you can split up this term, and then you can have this x go here, and this y go here, so that it's really 2 distributive properties here, okay? So when you FOIL it out, or I should say, when you distribute it out, you get this value, And look at that, guys. We get the exact same result as last time, okay? All right, so now, guys, let's do a quick example, okay? So I'm actually, well, okay, I'll do the FOIL method first, and then I'll do the other method, okay? So with FOIL method, right, we're gonna get our first term here. It's gonna be x squared. Our outer term is going to be negative x. Our inner term is gonna be x, and our last term is going to be negative 1. So when I take all this over here, it's going to be x squared minus x plus x minus 1. So it's just going to be x squared minus 1 because these are going to cancel out, okay? And then the other method that you could do is you could just say, all right, well, I'm going to do x and then x minus 1 plus x, I'm sorry, excuse me, plus 1 and then x minus 1, okay? So what I'm going to get here is I'm going to get x squared minus x plus x minus 1. And I'm gonna, these are gonna cancel. I'm gonna get x squared minus 1, guys, and we get the exact same values, okay? So you can use either method, all right? I just want to show you both. All right, guys, now this is super, super important, all right? Extremely important for the SAT, all right? Is these quick exponent rules for multiplication, okay? So what this means is that if we have two numbers, right? Or like two variables that are the same, right? So like x, for example, and they're to this exponent, you can simplify it as the same base to the two exponents added together, okay, guys? So let me give an example, okay? Let's say it's something like, let's see here, I don't know, y to the, let's say it's y to the x, right? And then it's multiplied by y to the 2, by y squared, right? Guys, this is going to be equal to y to the x plus 2, okay? Another thing that you might see sometimes is if we have a value, let's say it's like, I don't know, x to the n, we'll say x to the n plus 2, and then multiplied by x squared, okay? What is this going to be? So let me actually do it up here real quick. So what we're going to do here is we're going to have to add these terms together, right? So it's going to be x to the n plus 2 plus 2. And then what that's going to be is we can simplify down, that's going to be x to the n plus 4. All right, guys, so that's just another little trick you can use here, but this is going to be really important, all right? All right, guys, so we finally made it to that nasty problem, right? Now let's see if we can actually solve it now. Okay, so let's go ahead and work through it, okay? So we have all this nastiness here, okay? And if I scared you guys with this problem, that was my goal, okay? I wanted it to look super, super scary so that I could show you how simple it is, okay? And I actually made this problem myself, so just a heads up, you probably won't see something like this on the SAT, okay? This is just a challenge problem, right? So what we're going to have here is a plus b to the n plus 2 all over a plus b to the n equals a plus b squared over e to the x. All right, guys, so first step that I'm going to do here is I'm going to break up this term. All right, so here's what I'm going to do. A plus b to the n plus 2 power is the same thing as a plus b to the n multiplied by a plus b squared. All right, and this equals a plus b squared, and this is over e to the x, and this is over a plus b to the n. All right, guys, so these are being multiplied together, so these are actually going to cancel out here. And then guess what? These are also going to cancel out, because if I divide both sides, right? If I divide both sides, sorry, that's messy, but if I divide both sides, they're going to cancel out, okay? So hopefully you see that. So now what I have is I have 1 equals 1 over e to the x, all right? So now, what I want to do is let me multiply both sides by e to the x. I'm just going to go e to the x, and now, guys, I have e to the x equals 1, okay? All right, so hopefully you got all that. Now, what I'm going to do is I'm just going to erase all this stuff so we have enough room to talk about why this is so, so cool, okay? And honestly, why I love this problem so much, okay? So, what happens when e to the x equals 1? If e to the x equals 1, how do we solve this, okay? All right, guys, so there's two ways to do this, okay? And I'm going to show you the first way. So what we can do is we can actually take the natural log of both sides. So I'm going to take the natural log of both sides. And what's going to happen is I'm going to have natural log to the e to the x. That's going to equal natural log of 1, right? Okay, now from our logarithm rules, and if you don't remember this, it's okay, I'm going to do a video on this, but let me just give you a quick little review here. Whenever you have an exponent inside a natural log, you can actually just take it outside. So it's going to be x times the natural log of e. It's going to be equal to the natural log of 1, okay? All right, guys, now here's the thing. The natural log of e, well, remember, guys, natural log, let's say the natural log of x, that's equivalent to log base e of x, okay? So let's rewrite that out. This is going to be log e of e is going to equal natural log of 1. All right, guys, anytime that the base of the log is e and whatever's in the parentheses is e, this is just going to be 1, okay? So now I have x times 1 equals the natural log of 1. All right, guys, so now we just have x equals natural log of 1, okay? Now, what is our question? It says show that natural log of 1 must equal 0, okay? All right, guys, so now that we know all that information, let's see how we can prove that it's 0, because you might not know it. You might not even know that natural log of 1 is 0, okay? I'll tell you right now that it is, but let me show you why, okay? So let's go back for a second, okay? We knew that e to the x equals 1, right? But we know that x equals natural log to the 1, all right? But what value of x could also make this 1? Can you guys think of it? I'll tell you right now. If x equals 0, then we have e to the 0 equals 1, and anything to the 0 power is just 1. So now I have 1 equals 1. All right, guys? So x equals natural log of 1, but x also equals 0. Therefore, this symbol means therefore, the natural log of 1 must equal 0. All right, guys, that's our answer. If you have any questions, feel free to comment below, and I'll see you in the next video, okay? Make sure you stay tuned because I'm going to be producing a bunch more. And when you run through this whole playlist, guys, you will have your math foundation completely set for the SAT and GRE, so you can just start applying the foundation and then use reasoning skills to get that perfect score. All right, guys, I'll see you in the next video.